Okay, find a number with exactly 12 positive divisors. There's lots of ways, forms that this could take. The basic principle behind this is that suppose that a number n has the form n sub 1 to the I sub 1, p sub 2 to the I sub 2, to the p sub k to the I sub k. So suppose that is the prime factorization. Then the number of positive divisors is equal to I sub 1 plus 1 times I sub 2 plus 1 through I sub k plus 1. So that is the basic principle that we're going to use to solve this problem. So coming to the question about a number with 12 positive divisors. Well, there's a few ways that this can be done. First off, we note that, well, 12 can be just as equal, of course, to 12, now, which is 11 plus 1. And so that means that any prime to the 11th power will have exactly 12 positive divisors. So the divisors would be 1 p squared through p to the 11th power. So that would be an example of a number that has 12 positive divisors. So 2 to the 11th, which is 2048, would have exactly 12 positive divisors. Another way this could be done is by recognizing that 12 is equal to 2 times 6. And 2 times 6 is equal to 1 plus 1 times 3 plus 1. Sorry, 5 plus 1. And so that means that anything that has the form prime to the first power times another prime to the fifth power has exactly 12 positive divisors. The powers would be 1 q squared, q to the third, q to the fourth, and q to the fifth. And the other possibilities would be p times q, p times q squared, p times q to the third, p times q to the fourth, and p times q to the fifth. So that is a second form that would work. So for example, 3 times 2 to the fifth, which is 96, would have 12 positive divisors. And you should convince yourself that that's the smallest number that has 12 positive divisors in this form. Another thing that could work would be to recognize that 12 is equal to 3 times 4, or 2 plus 1 times 3 plus 1. And so anything that has the form p squared times q to the third would have all 12 positive divisors. So for example, if I list them out, it would be 1 q squared, q to the third, or you could have p times q, p times q squared, and p times q cubed, and finally p squared times q, p squared times q squared, and p squared times q to the third, the original number. So for example, for this one would be 3 squared times 2 to the third, which would be 9 times 8 for 72, would be a number with 12 positive divisors. The last way this could be done would be to recognize that 12 is equal to 2 times 3. So 1 plus 1 times 1 plus 1 times 2 plus 1. And so therefore any number that has the form p times q times r squared will have 12 positive divisors. So it'd be 1 r squared, or it'd be p times r squared, or q times r squared, and lastly p times q times r times r squared. So anything of this form would have 12 positive divisors. The smallest in this form would be 3 times 5 times 2 squared, which would be 60. And you can check that 60 has exactly 12 positive divisors.